Jeff? Does anybody have questions on anything? Yes?
Homework number 123.
All right, let's see. Okay. Blah, 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 blah. So let me see if I can't summarize some of this for us here. This is chapter 3. Oh, geez. 123, page 213. Some nice math symmetry going on there. The percent of licensed U.S. drivers that are female is 48.6%. How can I capture that mathematically in a much nicer, concise way? You can do it. If there's 48.6% of the licensed drivers are female, the probability of picking a female licensed driver is 48.6%. If 20% of the people in this room were going to vote in the California caucus, whenever that happens, then what's the probability that I'm going to pick somebody at random that's going to vote? 20%, right? Those are the same thing. 20% of the people are something. The probability I'm going to pick somebody to do that thing will be 20%. You guys with me? So not always, but very often percentages are the same thing as probabilities, because how do you make a percentage? Part divided by whole. How do you make a probability? Part divided by frickin' whole. Holy shit. All right. So every single statement they make, of the females, 5%, 5.03% are aged 19 and under. So how the heck could I capture that in a mathematical statement? Given what?
Female, given that they're 19.
Nope. Of the females, blah, blah, blah. So what do I know about the person?
Given female.
They are female, right? Of the females. So I know I'm talking about the female. So the probability, given female, 19 and under, less than or equal to 19, is 5.03%. How are we doing so far? I mean, like we did last time. We did a problem like this and said the most important thing in the first place is to capture all the English statements that are made and write it in a much more concise and better mathematical way. That was not a controversial statement at all. And then you can answer, part B is find the probability the driver is female. All right, I already know that because I took the time to write down what they meant. And then so they give you a lot more information. So continue in that fashion. Who asked that problem? Is that enough to get you going, or what's the?
I just wanted to make sure I was.
Oh, cool. All right. Well, if you're doing that kind of thing, you're doing it right. So one more. It says of the females, 81.36% are aged 20 to 64. 80.64%, I think I said. Probability what? Of the females, that percentage is age 20 to 64.
20 to 64.
What did I say? 81 point, whatever it says. 81 point blah, blah, blah. How do I say this?
20 to 64 given females.
Yeah, exactly. Cool. Why? And then you keep going. So you summarize what's told to you with the symbols, and then you can use formulas and you know what goes where. Okay, maybe. It's what you always do. It's what you do in any math class. You have this whole big thing written out with all these words. You find what's important and you give it variable names, and then you can plug them in the right place in the formula. That's the way it goes, right? Okay. Anything else from any homework stuff? Hopefully you're doing that because it's the best way to get ready for Thursday.
Can we go over what we're allowed to have on the formula sheet this time?
Oh, sure, yeah. I always forget about this thing. So obviously, you can have, this is going to be very direct. Probability of A or B. What's that formula?
the probability of
Yeah, you add them both together and you subtract off any you counted twice. That's the idea captured by that formula. What's the probability of A given B?
the probability of A and B over the probability of
I like it. And what you need to get over is if I said what's probably Q given R, it would be probably Q and R over the probability of R. So the form of it is there. You just replace A and B with whatever it is in the problem you're looking at. This is the form of it. You just replace them with whatever you're actually using. And then I can use this to figure out what the probability of A and B is. Bless you. It would be
the probability of A given B times B, the probability of B.
or the probability of B given A times the probability of A. Now what you're not allowed to write down, you can't write down the definition of mutually exclusive. You've got to know that. It's the definition. What does it mean to be mutually exclusive? If A and B are mutually exclusive. What about zero? What's zero?
The probability of
The probability of A and B has to be zero. You can't be both. If you're mutually exclusive, you can't be both.
What if I just write probability of A and B equals 0 on the thing but don't put mutually exclusive next to it?
Is it up here?
No.
Alright, that would be a problem. I like that. The short answer is no. Don't do that. What's it mean to be independent?
That one doesn't affect the other.
Probability given B is equal to probability of A.
Good, or vice versa. I like it. Right? Think about it. If B happens and A's probability does not change, doesn't that make sense to call that independent? B happened, A didn't care. Well, now I'm going to call that independent. That only makes sense. That's what independence means in real life. You don't depend on something else. Now, if B happens and A's probability changes, now the probability depends on if B happened or not. That's why we call that dependent. It's crazy. So that's why that is the test for independence. You just check, is probability A given B, is it the same as probability of A used to be? If they're different, dependent. If they're the same, A didn't care. So then I would call them independent. Please don't make a big deal out of that. That's exactly what I would hope independence would mean. And again, you can't write that up there. Right, that's what I'm testing you on, is if you understand what that means. Any other suggestions for the formula sheet for this probability double quiz? Anything I left out? There wasn't really that many formulas, right? I don't think I've left anything out. So that's it. That's all you can have on your sheet. Anything else, I don't care what it is, you'll lose points. Alright, so definitely bring the formula sheet with you. And remember, the really funny thing about formulas, in this class especially, is sometimes you don't want to use them. You want to stay away from them. It's easier just to count. If I give you numbers of stuff, you almost don't want to use these. They're going to throw you off sometimes. It's only when I give you probability of A is 0.7, the probability of A and B is 0.3, and then you got to use the freaking formulas, because then I don't have anything to count. I've got to just plug stuff into a formula. And there are a decent number of formula problems that look like that. Right? Look at me trying to get you ready. All right. Cool. Anything else? Okay. So Thursday we'll do that first thing after a few questions. If there's no more questions out of chapter 3, we're going to get into chapter 4.
Is there a lecture on Thursday?
Say again?
Is there a lecture on Thursday?
Oh, yeah. It's just a quiz. It's twice as long as a normal quiz, but that still won't take up half the time. So, yeah.
Can you go over I in section 3.3, number 80?
80? Okay. All right. So, by the point you got into part I, you've calculated a lot of things, right? But in general, so that's it for the formula sheet. Everything I write from now on is not on the formula sheet. If I ask you, this one says, what's the probability of C or B? without even knowing a damn thing about what's C or B or whatever, I can write the formula down. What's the formula?
Probability of B minus the probability of A or B and C.
And by the time you got into part I of this problem, you have figured out probability of C, probability of B, and the probability of C and B. Right? Is that cool? So often that happens in all of math, but here obviously, statistics is a part of math. You write the formula down for what they ask you, and you step back and say, do I have all of that? If you don't have all of that, you got to figure out what you're missing. But we do have this and this and this in earlier parts of that problem. So now you just got to throw the numbers in. If the answer I come up with, if I do this work and I get 1.7, is that okay? Why is that not okay? It's over 1. Don't do this. Oh my God, that's the quickest way to lose a lot of points, is to make me think that you don't realize that's bad. So if you look back at your work, like, I can't, just say, don't circle it, say, leave it and say, I can't see why. I know it shouldn't be this. I know it shouldn't be bigger than 1, but I can't see where I went wrong. Oh, then I'll be like, okay, thank God, at least they know it shouldn't be bigger than 1. You're not going to lose the concept points. If you just circle the damn thing, I got to take off concept points. I'm like, you apparently don't realize it can't be bigger than 1. That's bad. That's very bad. Do you guys understand? So if you don't see why, you just keep getting 1.7, whatever the hell you do, you just leave it and say, I know it shouldn't be this, but I can't see where I went wrong. And then I can help, and then I can say, oh, here, you made a little mistake, and you're going to lose a point or something. If it's a little tiny mistake, not a big deal. Okay, maybe. Okay. And the same thing with negatives, obviously, hopefully. You can't have a negative probability. I don't even know. What would that mean? It's going to happen in a different universe. I don't know what that... Chances are negative 10%. What's that mean? Okay. Yep.
Can you go over 96
This one, okay. I dislike that some of the problems are multiple choice. I hate multiple choice, but oh well. If I like a problem, but it's multiple choice, I just got to go with it. How do I check? If the question is, are A and B independent, what do I check? How do I show, or what do I check? What's the test for independence? How do I show?
Probability of B given A.
Okay.
Or equals the probability of A. Or B. Sorry.
Or the probability of A given B. If either one of these is true, then they are something.
Independent.
If B happens and A apparently didn't care, do you guys see how I read this? Do you guys see? Probability of A is something. If the probability A given that B happened is the same as that was, then apparently A doesn't care that B happened. Well, what would B do? Doesn't it make sense that we would call them independent then? Do you guys get that? Don't make more of that. It has to make fundamental sense. It didn't care that it happened. So, or the other way around. If B didn't care that A happened, same thing. The nice thing is you only have to check one of them. If one of them works, the other one will also. So on this problem, it says, are the hit being made by Hank Aaron, that's event A. The hit being made by Hank Aaron, and the hit being a double, that's B. Are they independent? You just have to check one of these two things. It's a multiple choice, so you can check. If you look in the multiple choice, every single one of them starts with the probability of hit by Hank Aaron given double. And then it compares it to something. So obviously they're doing, in this case, hit by Hank, they're doing this one. But, so you want to compare this. What do you want to compare this to? Compare the probability that it was hit by Hank Aaron, given it was a double. You want to compare that to the probability hit by Hank Aaron. You want to see if it changed. So you can immediately rule out any that compare it to it's a double. You can rule two of those things out. Bam. I love the way some of you guys are looking at me. But I'm a math teacher. I'm used to that look. Somewhere between I want to hurt you and please make sense now. Okay. Anything else from that chapter? That's our time. No, sorry.
99. I went to go look at the answer part, and it says there's supposed to be 3 parts, A, B, and C.
Oh.
But the question on the
All right. Let me see. That's funny. The cookie contains chocolate or nuts. Oh, they made their part A defining what they were, I think, right? Part A, the answers was define A to be this and B to be that.
Well, it says find the probability.
I know, but in the answers, they made their part A defining. Part B is the answer to part A, and part C is the answer to part B. Yeah. They just added part A for, they're like, how else can we screw these students over? Well, also, it's a free book, but and even the books that you pay $180 for, have you never seen a typo in one of those? Of course you have. There's always a ton of typos in any book. So I got to remember I didn't even notice that, so I got to remember to send that suggestion to them for the next edition. Is that cool? So number 99, don't freak out if you compare it to the answers. The answers have 3 parts because they added a part A. So just ignore part A.
Also on number 120, B and C are exactly the same question.
I like it. And I think in the answers to that one, that's the one I've seen before. In the answers, they do 2 different things, but in the question, they ask the same thing twice. So you just answer what they ask you. It's fine. You know what I'm saying? Just say, this is the same, so I think it would be the same thing I got. Yeah, that's fine. I like it. Maybe. And real quick, if you didn't realize from what I just said, there are answers in this book, if you haven't noticed. So it's a decent idea to check, but you should do it with a grain of salt because there are some typos. Not a crazy amount, but a decent number. Yes?
Can we do 86
Oh, so by the time you get to E, you will have figured out, let me see. Part D, you got to figure out what you need for part E. What's it mean for 2 things to be mutually exclusive? Or, mutually exclusive. You want to say it correct? If A and B are mutually exclusive, what's that mean? The probability of A and B must be 0. I like it. Right? So on that question, it says, are these mutually exclusive? In part D, you should have figured this out. You had to figure out the and to do part D. So if it's not equal to 0, you're done. Then you know it's not mutually exclusive. I like it. Is that cool? Who asked that question? So if you did part D, you have to be able to do part E.
Can you do part C?
Okay. So this depends on you doing part A correctly. If you don't do part A correctly, the rest of it goes to hell. So if I'm rolling 2 die, it could be both. It could both be 1s, or they could be 1 2, 1 3, 2 1, 3 1, so forth. Right? Once you have that complete list, you can just count your way to the answers. So part C says, let the sum of the 2 rolls is at most 7. So I'm going to count this first one up to 1 6. It's a most 7. And I'm going to count the next one up to 2 what? 5. I'm not going to count 2 6. That's not going to be counted, right? For part C, right? And the next one I'm going to count up to 3 4. Not the other 2. The next one I'm going to count up to 4 3. And the next one I'm going to count up to 5 2. And then the last one I'm going to count only 6 1. So you just got to count all these. Is that cool? Right? You just have to count your way to the answer. How do you get any probability? The number of things that match what I'm looking for divided by the total number of things. So how many things add up to at most 7 divided by 36? That should be how big your list is for part A. Anything else from homework? Gotta take that as a no. Okay, so let's get to chapter 4. Yes. And that was not a question. Okay. All right, and I sort of gave us a preview of this, so I'm going to do some lecture, and then, as you should be used to by now, I got a little handout. I think that works really well when you guys actually get to work on something together. So instead of, actually, this should look very familiar. When we did the classes, and then we did the relative frequency, do you guys, now looking back, do you realize I could have called those probabilities? So if you made a class from before, if I was doing a histogram, and I had a class from 31 to 40, and then from 41 to 50, blah, 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 to 5. And then I do the relative frequency. Let's say the relative frequency here was 10%, and here it was, you can do it, Jeff, 25%, blah, blah, blah. What's the probability that I pick something that's in this class? 10 freaking percent. So I could have called this the probability of X, if these are my X's. Let me let you absorb that. Anytime you calculate a percentage, it could very easily relate to a probability of something. If 10% of the people in this room are left-handed, there's a probability of 10% of me picking somebody who's left-handed randomly. We go together. All right, how are we doing so far? So, in my attempt last time to explain a certain idea, I wrote something in this form because it's just the easiest form to look at. So I'm going to go directly to this form. So now I'm going to have a distribution of probabilities. All that means is 100% total probability. I'm going to distribute that amongst a lot of choices. So what I always go to is if I ask somebody how many TVs they have. If I ask a lot of people, right? And some people said no TVs, 1 TV, 2 TVs, 3 TVs, 4 TVs. Cool. I like it. And then here it could be, let's say that 5% said no TVs, 28% said 1 TV, 31% said 2 TVs. Let's see where I'm at. 15% said 3. Now what's got to be here for 4? What's the 4th one got to be?
Whatever it takes to add to 100.
So how do you figure it out? What would you do to figure out what goes here?
Add the 1 minus 1.
Yeah, 1 minus all of these, right? I like it. Doesn't that sound familiar? So let's see, what I got? 33, right? 33, 64, 79. So this would be what? 21. Is that cool? 3, 6, 8, 9, 10. Yes, okay, good. I like it. Let me let you figure that out. Is everybody cool with the fact that I didn't talk to anybody? Notice I didn't leave the room. I didn't talk to anybody. I'm just pretending like this is what happened. I talked to people. 5% of the people I talked to said no TVs. So if I talked to 100 people, how many people said no TVs? 5 of them. I like it. You wouldn't? Sweet. So let me ask you a couple questions here. What's the probability somebody told me that they had 3 TVs? Good. I just want to make sure. It's a funny, weird question, but sometimes people can't read this. They're not sure how to read this. Probably had somebody had 3 TVs. It's 15% chance. What's the probability that somebody had at least 1 TV?
33.
What's at least 1 TV mean? It means 1 or 2 or 3 or 4 or 5. Or means add, right? So the quicker way, you could add all of these. Oh shit, we're doing this again. But the quicker way is 1 minus the one I left out, because they all add to 1. So what do these have to add to be? 1 minus this. They got to be the rest of 1, don't they? So what's the probability of at least 1? In a lot of situations is 1 minus the probability of none. Because those are opposites. What's the opposite of at least 1? None. If I said at least 1 person in this room is standing. Is that true? Really? Is somebody standing? At least one person. Nobody's standing, right? So the opposite of at least one is none. I had to sit down and make it not true, didn't I? So I had to make it none. So the opposite of at least one is none. Therefore, the at least one probability is 1 minus the opposite. And you can imagine, what if I made this, what if I had people saying up to like 20 TVs? Right? You know, I've got 10 TVs in my room alone. Right? And I said at least, you know, you add this to this, to this, to this, to this. No, 1 minus that freaking thing, please, dear God. Right? So much quicker. Maybe. Okay. All right, so let me attempt this now. So I wanted to show you the form of this. If there were 100 people, what would the list have looked like of answers? The list of answers.
Smaller amount.
If there were 100 people, again, remind me, if there were 100 people, how many people had no TVs? 5. So there would be 5 zeros. And 28 ones. No. So if I wanted to calculate the average, the way that we've calculated averages before, that would so desperately suck. Right? I don't want to write that freaking list out. Shit. All right, you guys kind of with me? And what if I would have done this? Now it's out of what? It's out of what? Tens, hundreds. Holy shit! Now there would be 51 people said no. Screw that. All right. So what I want to do, every time we learn a different way to distribute probabilities, every time we learn a different probability distribution, we want to figure out a better, quicker way to figure out the mean, and probably also the mean and the what tells me the best information, the mean and the standard deviation. There it is. Right, those two together tell me what the center is and how far away my data gets from the center on average. Those two are the quickest, most useful summary I can tell anybody about any set of data. That's why we did all that work on the standard deviation. It's better than the range. It just discriminates between data sets better than the range does, if you remember that. If not, just take their word for it. All right, so let's leave this up here for a second. Let me make a slightly easier problem because I want to develop a quicker way to figure out the mean than writing what this list might be. Right? Let me take this back to what it was. It's bad enough like this. Okay, so watch this. This is kind of neat. And again, I always show you why things work. If you don't totally get why they work, that sucks, but it's still, you can still do the actual procedure. Right? You just don't know why it works, but you know, it kind of sucks. So try to see why this works. So let me make an easier one to look at here. And actually, let me do this way. Let's say I had this kind of data here. What kind of data? Hold on. Let's say I had 0, 1, 2, 2, 2. That's not a 2, Jeff. Good job. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I like it. So I'm going to use the old way of doing things. And actually, do you guys understand how this distribution means there's a lot of repeats? I love it. So now I'm making a smaller list of data that I can attack with the old way of calculating the mean, and I'm going to try to put it in a way that relates to this. And then we'll have a nice shortcut to get the mean from this setup. Just go. It'll be all right. So how would I calculate the mean? What would I do? The mean is the sum of them divided by n. So I would say there's 1 0, right? And 2 1s. And 3 2s. And 1 3. And 3 4s. Right? Is that cool? Because there's repeats. Okay. Divided by what?
10.
Yeah, there's 10 total, right? Yeah, let me stop there for a second. I'm writing it in a weird way. Some of you guys might realize why. I'm trying to relate it to that form. So if I do this, I get, what do I get here? I get 2, 8, 11, 23, I get 2.3, I think, right? So somebody beat me to it or no? You guys are like, no, dude, you do the work. Nice job. Yeah, 2.3. So I know the mean is going to be 2.3. So let me mess with this one more way and make it look more like that does. Isn't this 1/10 times 0 plus 2/10 times 1? How the hell do I do that? Everything's been divided by 10, right? So it's 1 over 10 times 0, 2 over 10 times 1, 3 over 10 times 2. And now that looks a lot more like 0, gather, with a 10% sitting next to it, right? 1 with the 20% sitting next to it. Do you guys see what I'm saying? What percentage of my data is 1? 2 out of 10, which is 20%. So apparently, what do? I take the value times its weight times the probability. So whatever the value is, I multiply it by the probability, and then what do I do with all those? What does it say to do? Add them. So I multiply the value times its weight, and then I add those, right? So let's see, if I do that, let me